Happy Tuesday, everybody. Thank you to Caroline Dill for the meme today. Let's get this tremendous Tuesday. Pollen is killing me. If I sneeze, I apologize. I'll try to lower the volume during those times. So, homework review, because not a whole lot of people were getting it. Basically, oxidation means you are losing electrons. You are getting more positive. Reduction means you're getting more negative. So our goal was to figure out, are these redox reactions, which the definition is a reaction where you change electrons. So if our numbers change, it's a redox reaction. And then if it is, which one's oxidizing, getting more positive, and which one's reducing, getting more negative. So let's check it out. Let's look at our 5 rules. I'm going down the line. So my rule number 1 was free atoms are 0 charge. Do I have any free atoms? I see one right here. It's by itself. 0. Br is by itself. That would be 0. Rule number 1. Rule number 2 says ion charge. Do I see any ions? Any little pluses or minuses? Nope. Number 3 says the compound sum they need to add up to be 0. I don't see anything yet. Number 4 says anything in group 1 is plus 1, anything in group 2 is plus 2. Do I have any group 1ers? Is K in group 1? Yes, it is. So K is plus 1. All right, all I have left is chlorine and bromide. So I need to figure out those. That's not H, that's not O. Group 17 is -1. Are these in group 17? There's chlorine, there's bromine. Yes, they're both -1. Cool. So, is this a redox reaction? Basically, did anything change? K went from +1 to +1. No change. Bromine went from -1 to 0. I have a change. Yes, it's a redox reaction. Second question, which one oxidized and which one reduced? Bromine went from -1 to 0. It got more positive, which means bromine oxidized. Chlorine went from 0 to -1. It got more negative, so chlorine reduced. All right, second problem. Rule number 1. Free atoms are 0 charge. Do I have any free atoms? Nothing's by itself. Rule number 2. Ion charges. Any ions? No pluses or minuses? That's not a problem. Number 3. It adds together to be 0. Doesn't help yet. Number 4. Anything in group 1 is plus 1. Anything in group 2 is plus 2. Do I have any group 1ers? Hydrogen, lithium, Na. There's Na. That's plus 1. There's hydrogen. That's plus 1. Na plus 1. Hydrogen plus 1. All right. Group 2. Any magnesium? No. Let's see. Any H's are plus 1. Any O's are -2. Hey, there's an O. That's got to be -2. There's an O, -2. Alrighty. What does it say next? Group 17 will be -1. Do I have any group 17s? Any fluorine, chlorine, bromine, iodine? I have chlorine, so chlorine's -1. Cool. So now I'm stuck with Cu. What do I do with Cu? Well, rule number 3 said that everything has to add up to be 0. I have 2 Cl's here, which means that charge is -2. So if I have 2 -1s here, then this needs to be +2 to balance that out. This has a -2 and a +1. Put those together, you get a -1. And I have 2 of them, so 2 -1s gives me -2 here, so this has to be +2 to balance it out. So, is it a redox reaction? Na is +1, Na is +1. O is -2, O is -2. H is +1, H is +1. Cu is +2, Cu is +2. Cl is -1, Cl is -1. There was no change here. No, this is not a redox reaction. And nothing oxidized or reduced because it's not even a reaction. Last problem. Number 1. Free atoms are 0 charge. Mg's by itself, iodine's by itself. That's together. Number 2. Ions, no plus or minus. Number 3. Adds together to be 0. Doesn't help me yet. Number 4. Group 1 is +1, group 2 is +2. Do I have any group 1ers? Any hydrogen, magnesium, Na, lithium? Nope. Any group 2ers? Magnesium's in group 2, so that means magnesium is +2. Hydrogen, oxygen. No, I'm looking for iodine. Group 17 is -1. Iodine's down here in group 17, so that's -1. And I have 2 of them, so that balances out with my +2. So rule number 3 is checked. All right, magnesium is 0 here and +2 here, which means I had a change, which means yes, it is a redox reaction. So what changed? What did magnesium do? From 0 to +2, it got more positive. That means it oxidized. Iodine went from 0 to -1. It got more negative. That means it reduced. There's the homework. So, I hope this clears it up. Today, from 3 to 5, I will be having a Zoom call. It will be my first one. If you guys have questions, please feel free to join the session. I'll post the link in the group me today. All right, so let's start with a quick little mini review. So, Cl2 plus H2 gives us 2HCl. How would we go about doing this if we're figuring out if it's a redox reaction? I'd go through my list of 5 things, which you should have out right now to check. Number 1 says free atoms give us 0. That means my chlorine's a 0, my hydrogen's a 0. I don't know what that is yet. Number 2 says about ion charges. Do I see a plus or a minus up here? Nope. Number 3 says it needs to add to be 0. Doesn't help me yet. Number 4 says group 1 is +1, group 2 is +2. Do I have any group 1ers? Yes, hydrogen. So hydrogen's +1. And then it says hydrogen's +1, oxygen's -2. Group 17 is -1. Group 17 has chlorine in it, so that's -1. All right, so is this a redox reaction? Chlorine is 0, chlorine is -1. Yes, this is a redox reaction. And from what we talked about for homework, which one got oxidized and which one got reduced? Chlorine went from 0 to -1. It got more negative, so chlorine reduced. Hydrogen went from 0 to +1. It got more positive. Hydrogen oxidized. Okay, so now we're going to add in another piece called oxidizing and reducing agents. Now, what is an oxidizing agent and a reducing agent? Now, an oxidizing agent is something that gains electrons and is reduced. Don't think too hard about this. An oxidizing agent is something that gets reduced. Okay, and a reducing agent loses electrons and it gets oxidized. Uh-oh, what the heck's going on here? So why would something that oxidizes be reduced and something that gets reduced, something that's reducing getting oxidized? Why is there this weird flip-flop here? So an agent is something that causes the opposite effect to something else. If you are oxidizing somebody else and making them more positive, that means you're getting more negative, which means you're reducing. If you're reducing somebody else, that means that you are making them more negative. And if you're giving them negativity, that means you're getting more positivity, which means you're getting oxidized. So it's almost like the weak base, weak acid, strong base, strong acid thing we talked about. So the question becomes, what is our oxidizing agent and our reducing agent? So chlorine goes from 0 to -1, right? It's getting more negative. And if it's getting more negative, that means hydrogen's getting more positive. So if chlorine's getting more negative, chlorine got reduced. But that means that if it got reduced, it's also the oxidizing agent. Because it's helping hydrogen get more positive. That's hard to read, I'm sorry. This is oxidizing agent. If chlorine's reducing, that means it's helping hydrogen get more positive. And guess what? Hydrogen is getting more positive, which means it's helping chlorine get more negative. And so if it's helping chlorine get more negative, that means that it's the reducing agent. Another cool way to think about this is an agent as a helper. An agent is helping somebody else do the opposite of what you're doing. It's like how a leader lifts others up above themselves. Chlorine wants to make hydrogen happier, make chlorine more positive. So it becomes more negative. It's helping hydrogen get more positive, so it is oxidizing hydrogen. And hydrogen is reducing chlorine. All right? So this is the layer we're adding. So we got to get the charges. We got to make sure it's a redox reaction in the first place. And then once we know those two things, we got to be able to tell what's the oxidizing agent and what's the reducing agent. We're just building on it. So my first example for you. I've got C2H6 plus O2 gives us CO2 plus H2O. My rules. I have 5 rules. Number 1 says free atoms are 0. O2 is a free atom. That's a charge of 0. Nothing else a free atom. Darn. Alright, number 2 says ion charges. Any ions? Nope. Number 3 says compound sum is 0. Not going to help me yet. Number 4 says group 1 is plus 1. Group 2 is plus 2. Any group 1s or 2s? I see a hydrogen. That's plus 1. And I've got 6 of those. Hydrogen. That's plus 1. Then it says hydrogen's plus 1. Oxygen is minus 2. Here's oxygen, minus 2. Here's oxygen, minus 2. All right. All I'm left with is my little carbon. So carbon's weird. Remember when I told you it could be plus 4 or minus 4? This is where we're going to see that. So here, let's look at this one first. We have 2 O's, right? And they're both negative 2. Together, that's going to be negative 4. So to make this balanced as a 0, like rule number 3 says, to balance a negative 4, C has to be plus 4. So C is plus 4 here. Let's look at this one. Here, I have 6 plus 1s, right? Which means I have plus 6. I have 2 C's. Hey guys, future Mr. Brown cutting in here. I actually made a really silly mistake here. So H's in our rules are plus 1. And we know that C is supposed to be plus or minus 4, right? Well, the rules say number 3 first, that it has to add up to 0. So if I have 6 plus 1s, that's plus 6. If this has to balance out, right? I have 2 of something, and that has to balance out to plus 6. 2 of something. So if I have 2 of something and that needs to balance out with 6, well, then what does each one need to equal? 3. Each carbon has to be a 3 to balance out this plus 6. So this would be minus 3. Because 2 minus 3 is giving me minus 6, and that balances out my positive 6. So I wrote a silly number down. Don't mind that. All right. So is this a redox reaction? Well, I know my carbon's changing. Hydrogen's plus 1. Oxygen goes from 0 to minus 2. Things are mixing up here. So this is definitely a redox reaction. So what is oxidizing and what's reducing? Let's do like we did with the homework. Carbon's going from minus 4 to plus 4. That's getting way more positive. So with our oxidizing camp getting more positive, we have our carbon. Anything else getting more positive? Hydrogen's not changing. Oxygen's getting more negative. That's not changing. Reducing. Anything reducing? Getting more negative. Hydrogen's not changing. Oxygen's going from 0 to minus 2. Oxygen is reducing. All right, so step 1. Step 2. Step 3 is what's my oxidizing agent? And what's my reducing agent? So who is getting more positive? This piece is getting more positive, right? So if this piece is getting more positive, that means that our oxidizing agent would be the O2. The O2 is helping this piece get more positive. Who's getting more negative? The oxygen. So who's helping oxygen get more negative? The C2H6. It's as simple as that. Don't overthink it. Which piece is getting more positive? The other one's helping it get more positive. Which one's getting more negative? The other one's helping it get more negative. Those are the 3 steps so far. Is it a redox reaction? If it is, then who is oxidizing and who's reducing? And if we know that, then who is oxidizing who? Who's the oxidizing agent and who's the reducing agent? Let's look at example number 2. Iron plus oxygen gas gives me this load a mess. What do I do with it? Well, first off, is it a redox reaction? Let's look. What's the charge of my number one? My number one thing I need to check for is what is my free atoms. Do I have any free atoms? Yes. Iron's free. Oxygen's free. That's not. All right. So do I have any ions? Nope. Compound sum's going to need to be 0. Group 1. Anything in group 1? Nope. Group 2? Nope. Hydrogen plus 1. No hydrogens. Oxygen's minus 2. There we go. I know that oxygen's minus 2. There's no rules about iron. This is group 17. Blah, 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 blah. So I need to figure out what is iron. So I have 3 minus 2s, right? 3 negative 2s. So that's going to give me negative 6. So what would this charge have to be to balance out a negative 6? This would have to be a plus 6. Together, these two irons give me a plus 6. And if I have 2 irons, 6 divided by 2 gives me 3. So my charge here is going to be plus 3. If I just blew your mind and you're confused, I have 3 negative 2s. That gives me negative 6. Now I can have 2 plus 3s, and that gives me positive 6. These two numbers cancel each other out. That's why I'm using that number. Iron's going from 0 to plus 3. It is definitely a redox reaction. We got some change going on. So step 1, yes, it's a redox reaction. Step 2, what is being oxidized and what's being reduced? Iron is going from 0 to plus 3. It's getting more positive, which means it's oxidized. Oxygen's going from 0 to minus 2. It's getting more negative. That means it's reduced. Cool. And now my final step that I just added. What is my oxidizing agent? And what is my reducing agent? My oxidizing agent, who is helping the other one get more positive? So I know my iron is getting more positive, so the person that's helping my iron get more positive is oxygen. And I know my oxygen is getting more negative, so my iron must be helping him get more negative. So really, these guys, especially if it's a free items, they're just helping each other, so you can pretty much just flip those to get your answer. Okay, I'm expecting this to be a bit of a brain twister. If this is confusing you, please, please, please read page 439, or join me in my Zoom meeting from 3 to 5 and ask any questions you like. The link should be in the GroupMe around 2:30. I had 3 problems for you, but I really don't think you need 3. I think you only need 2. So, 2 problems. Do what I just did. Find me, is it a redox reaction? If it is, then what is oxidized and what is reduced? And then once you know that, what is the oxidizing agent and what is the reducing agent? Let me know if you have any problems, and with that, good luck.